Hi there, this is Penelope and this is a short video on optimization, and it's where we use the first derivative test to decide whether we've got a maximum or a minimum. So first up, we've got a problem here, y equals 2x cubed minus 6x squared minus 18x, and the first step of optimizing is to find where the derivative is equal to 0. So let's find the derivative. And we see then that it's 6x squared minus 12x minus 18. Let's make that equal to 0. We've got a common factor of 6 for each of those terms, so divide through by 6. That leaves us with x squared minus 2x minus 3 equals 0 that we need to solve. This is quite an easy one to solve, so we can actually factorize it, and then we end up that x minus 3 is 0, or x plus 1 is 0, and that gives us that x is 3, or x is negative 1. Now we need to find the corresponding y values, so we put x equals 3 into the calculator and we get y equals negative 4. Put in x equals negative 1 and we get y equals 10. Now that's all the first step. So now the second step is where we have to look at the slope around those 2 points. So the best way to do it is to set up a table and then go through the bits. So the first bit you would look at would be x to the left of 3, where x equals 3, x is greater than 3, and so on. So I've already pre-filled this in, and I need to divide that in half because that's then both turning points. Where we've got x is less than 3, the derivative is negative, so that means we have a negative slope. When the slope is 0, it looks like that. On the right-hand side of x equals 3, the derivative is positive, so it gives us that shape. Similarly, we can do the same for x is less than negative 2. It gives us that shape, a positive slope, where x is equal to negative, sorry, did I say negative 2? Sorry, x is less than negative 1, it gives us a positive slope. When x is equal to negative 1, it gives us a 0 slope. And where x is greater than 1, it gives us a negative slope. So you can see if I draw those, it's kind of like that, and if I draw that, it's like that. Now, that tells us clearly that we have a minimum here, and it's a local minimum. Here we have a maximum, and it's a local, if that's what you need to call it, or it might be a relative max or a relative minimum. That allows us to, if this was an applied function, that would allow us to find the minimum value of whatever, or the maximum value of whatever, and it certainly allows us to draw the graph. So you can see there that the maximum is at negative 110, and the minimum is at 3, negative 54.